Hi, this is the online version of my glitch codec tutorial workshop. My name is Nick Breeze, and I'm a new media artist, thinker, and organizer. So, in the mid-2000s, I went to film school in hopes of becoming a filmmaker, but I quickly realized that film was a bit too expensive for me, and so I would be forced to use film's much cheaper little brother, digital video. And the trend at the time in film school was to get your videos to look as much like film as possible. But it wasn't too long into film school before I realized that something wasn't right about this approach. It seemed counterproductive, so I gave myself an ultimatum. If I was going to keep shooting on digital video, I needed to establish a relationship with the digital medium. That's what I told myself. And so after some thinking, I decided that meant making a video straight from binary code. Um, that I realized that was damn near impossible, but after doing some research and experimenting, I realized that I could open up and see the code beneath a video file that already existed. And so I started to experiment and mess around with that. And what resulted were these harsh, noisy, colorful pixel artifact explosions. And I was convinced that these were digital's natural aesthetics. And then quickly I came across others on the internet doing similar work, and some of them did so under the guise of glitch art. And that sounded cool, so I began using the term to describe my work to my peers and film professors in my efforts to explain to them exactly what it was I was doing. Um, After lots of experimentation, research, and work, I realized, of course, that I already had a relationship to digital technologies, that we all have a relationship to digital technologies. And this relationship went beyond just my work in video. Um, and this glitch approach radically changed my perspective and drastically informed that relationship. And though I made a lot of videos and web art as a result of these experiments, I more recently realized that the heart of what I was doing was in the process of making these things. So I put together this workshop to share that process. And by process, I don't just mean technically, but ideologically as well. The idea is that this glitch codec tutorial is equal parts technical workshop and theoretical lecture. So I explain not only my tools, tips, and tricks, but my feelings, philosophy, and ethic as well. So a good place to start is defining glitch art. Um, and in order to do that, we'll need some JPEGs and a text editor. So do a Google image search and then take an image and drag it onto your desktop. Anytime you're glitching, hacking, or generally experimenting with digital files, it's always good to make a backup just in case. It's just good practice. So you want to do that. Then once you've done that, double click your JPEG and it should pop up in your default image viewer. So the computer knows that a JPEG is an image file, so it assumes you want it opened in your default image viewer. But really a JPEG is just a container for ones and zeros, for binary code. The same is true of every other digital file, DMGs, MOVs, MP3s, whatever. What we're looking at in this image viewer is simply your default viewer's interpretation of the code that makes up this JPEG. So if we control-click the JPEG and hover over Open With, we'll get a list of other applications on your computer that can open up images. And if you click on the bottom where it says Other, then a window will pop up that'll show you all your applications. You want to make sure that where it says Enable, you have that set to all applications. And then scroll through there and choose Text Edit, and then open it up with that. And what you'll get is an ASCII representation of the binary data of your JPEG. So these two things are the same. It's just one is the text edit's interpretation of the data, and the other is your default image viewer's interpretation of the data, but they're the same file that you're looking at. So go into your text edit and scroll down into somewhere into the middle and just type in some stuff into your editor and then save it. Then go back to your image that's opened up in your image viewer and click it, and it's glitched. And so there's a whole bunch of stuff we can do here. If you go back to your text editor, you can copy a big chunk and then paste it and then save that and then go back to your image. You can also go into your text edit and use the find option and find and replace and turn all your G's into Z's or something, and then go back to your image and view it. And each time it'll just get more and more glitched. So glitch art is often this kind of hacking. This technique in specific is known as data bending. Glitch art is about breaking through some of the assumptions and interfaces that govern our relationship to computers. And through this kind of playful experimentation, reorient our understanding of digital technologies. So in order to take part in this tutorial, you're going to need to download just one file, and that's a disk image file that I made called glitchcodec which should be linked either below or somewhere around this video. So go ahead and click on that, and while that downloads, I wanted to sort of present a particular kind of framework for this tutorial. And because quotes are good at those kinds of setups, I want to start with one by a prominent American deconstructionist named J. Hillis Miller. And Miller described deconstruction this way. He said, "Deconstruction is not a dismantling of the structure of a text, but a demonstration that it has already dismantled itself. Its apparently solid ground is no rock, but thin air." And this is the kind of, in some ways, this is the kind of perspective or approach to glitch art that I'm pushing for or hoping to get to by the end of this tutorial. And glitching is a kind of tactful exploitation of systems, of digital and technological systems. And this glitch codec tutorial is about exploiting one very particular kind of hack. And hacking is all about making use of other kinds of uses, and glitching is all about hacking. And so glitch art can be about raising awareness of these other kinds of uses. And I think this awareness is important because it can establish a kind of critical relationship between users and computers that isn't normally there by default. Um, and it's that kind of critical relationship I'm hoping to create for others by presenting this process that, though systematic, is all about destroying systems or instigating a kind of self-destruction of systems. So this hack always exists in the present and never in the past, because every use of the glitch codec necessitates a new destruction of a codec file at the code level, creation by destruction. And I'm hoping that is going to make a little bit more sense at the end of this tutorial. Destruction, in this case, is used to refer to this demonstration of the system's appeared self-dismantleization. And the reason I say appeared self-dismantleization is because computers don't really make mistakes. Users input stuff and machines output stuff. A glitch is really just an unexpected output, which by catching us off guard makes us aware of the medium, its structure, and its politics, which are really there the whole time. Um, but the error is actually a human one, which either belongs to the programmer or belongs to the user. But we prefer to place the onus on the machine, so we call this occurrence a glitch. Now, when somebody intentionally or desirably instigates a glitch, that can be understood as glitch art. Um, and understanding the nature of glitch art, the means, the methods, and the situation in which it's invoked can establish that kind of critical relationship to digital media and culture that I was talking about. So the glitch codec tutorial itself can be discussed as glitch art, but it's important to note that this tutorial is something that's always experienced, not just observed. It's a process, not a product. So once that .iso finishes downloading, you want to go ahead and burn it on a DVD. So if you're on a PC, you can use whatever your standard CD or DVD burning software is. It probably has an option like burn disk image or burn ISO. You want to choose that option and then open or import the glitch codec tutorial.iso file you downloaded and then burn it on DVD. If you're on a Mac, you're going to run disk utility, and then in the file menu, you're going to choose open disk image and select the glitch codec tutorial.iso file so that it shows up in your list of volumes on the side. And then you're just going to go ahead and choose that and burn that by clicking burn. So why are we doing this? So this tutorial is all about hacking video codecs. And in order to do that, we need a particular kind of access and a particular kind of freedom. And what you're burning is a customized version of the Ubuntu operating system that I made for this tutorial. And what it's going to allow you to do is run that operating system live from the DVD without making any kind of changes to your regular operating system and setup on your computer. Because Ubuntu, as opposed to Microsoft Windows or Mac OS X, which are commercial or proprietary operating systems, Ubuntu is a GNU Linux distribution, which is an open source operating system. So the first thing we think about when we hear open source is that it's free, and that's true. Linux is free in that you don't have to pay for it. But free here implies also, more importantly, a certain kind of freedom that you have. Because when you buy commercial or proprietary software, you're not really buying it, you're licensing that software. And licensing is kind of like leasing a car versus buying a car. When you buy a car, it's yours, and you can paint flames on the side and put spinning rims on it and a crazy sound system, and then when you're bored of it, you can sell it. But when you lease a car, you're given the keys and you can drive it around, but you're not really authorized to make crazy modifications to it, and you can't really sell it. So this matters to us because we need access to what's called the source code of these video codecs. So when computer programmers write software, what they create is the source code, and the source code is is computer language, which, just like any kind of human language, is something that we could learn to read and write. And then that source code is run through a compiler and gets turned into object code, which to us looks like gibberish, but to a computer can be run and executed like a piece of software. So when computers run or execute a software or an application which we can then use, that's the object code. When a programmer writes or makes changes to that piece of software, they're working with the source code. So an example of a closed proprietary piece of software is something like Microsoft Office, which you're not allowed to make changes to, but you can be licensed to use it. So in this way, a specific kind of confined relationship is sort of imposed on you by the manufacturer's special interests, which is not the case with open source software, which you can run and use, but you also have the freedom to make modifications and improvements on. An example of this would be something like OpenOffice instead of Microsoft Office. And so because we want to hack the source code of these video codecs, we need to have access to that source code and the freedom to hack and tinker and experiment with it. Once you're finished burning the DVD, you want to reboot your computer with the DVD still inside in order to boot from that DVD. So the way you do that on a Mac is by holding down C during the reboot. If you're on a PC, what you want to do is click F12 when you see it in your prompt during the reboot, and then you might also have to click CD or DVD if it gives you an option. And what this is going to do is boot the operating system live from this DVD instead of your operating system on your computer. And it's going to do this by bypassing your hard drive and all that. So it isn't actually going to affect your operating system or your regular setup. Instead, it's just going to run this Ubuntu operating system live from the DVD. So I'll show you what that looks like. Okay, so I'm booting up my computer with the DVD inside. Hitting F12 because I'm on a PC. And then I'm choosing the CD DVD option. And then it's going to boot into this black screen with some white text with some simple instructions. It says for the default live system, press enter. That's what you want. You want to just do the default live system. So you click enter. And then it's just going to start to load the operating system from the DVD. You're going to see the a white Ubuntu logo appear in the middle of the screen. And then it's probably going to sort of pulsate for a while. Sometimes it even gets stuck at this part. If that happens, just reboot and try again. But yeah, otherwise you just wait for a little bit. Okay, so when that's done loading, you're going to be prompted for a password. I'm just going to click where it says glitch, and then the password is 01010, and then you hit enter. And then that's going to boot you into the operating system. So before we start breaking things, we need to learn how to run and make some stuff first. And what we're going to be using is something called the terminal, which is a command line interface which we're going to use not only to run our glitch codec, but also to compile our source code. And the terminal is a way of interfacing with a computer that doesn't pretend to be some kind of real-life object like a folder or a trash can, because we don't need it to pretend to be those things. So we're gonna use it first to run a video through our glitch codec, which, despite the name, isn't actually going to glitch anything just yet. It's just going to compress it because we actually haven't hacked anything yet, and I'll explain that in a bit. But first, let's just run something through it. So go ahead and open up a terminal and type in glitch codec, one word. This lets the computer know that we want to use our glitch codec. Then put a space and type in -I, which stands for input, and then another space, and the name of the video you want to input. So in the glitch home folder, I have some sample videos there that you can use, or you can drag and drop a video from a USB stick onto that folder, whatever you want. So I'm going to run a video called nick.mp4, and this is case sensitive, so it's important that we type it in exactly like the file is named. And then lastly, we're going to put one more space and type in the name that we want our newly compressed video to be. So I'm going to type in compressednick.mov. That could be any name so long as you keep that .mov afterwards. And then go ahead and click enter, and it's going to start compressing our video. So for various reasons, like streaming video on the web, DVD encoding, television broadcasting, etc., videos need to be compressed, and what that means is that they need to look and play as best as possible while becoming as small a file as possible in order to most efficiently achieve all these reasons. So codecs are a series of compression algorithms used to achieve this compromise between a file's size and quality based on assumptions made about what we won't notice or don't need to see or hear in a given media file. So there exist various different kinds of codecs and algorithms that do this, and they all do it in different ways. Some sort of do it on a frame-by-frame method. Others sort of use motion vectors, sort of looking at the difference between frames over the course of a particular time. And we don't really need to get into the details of how this works, but it's important that we understand that they all work differently, and so all these videos are made differently, and this means that they can break differently, and that's what we're about, breaking them. Okay, start hacking some stuff. Go up to the menu where it says Places and select the home folder to open up our glitch home folder. Then open up the FFmpeg folder, and then within that the libavcodec folder. You're going to want to scroll down till you find a file called h263data.h and open that up. This is where we're going to start hacking. But first, remember, it's important to always make a backup of any file that you're going to be tinkering with, like we said before. So I've already made a backup of this particular file, and you can find that in the glitch home folder. But in the future, as you start to mess with some of these other files, remember that it's always important to make a backup. So what we're looking at here is part of the source code to the H.263 codec. And like we said before, source code is human readable, which is why you can make some sense of this. Scroll down a bit to a comment that I've made there. And what we're going to do is start messing with those pink numbers. So go ahead and change some numbers. I'm going to change some arbitrarily and then save it. Now we're going to open up a new terminal and type in cd, which stands for change directory, space ffmpeg, and hit enter. And once we're in there, we're going to type in make space install and hit enter. And now what we're doing is that we're taking our newly modified source code and we're compiling it and turning it into new object code to make our new glitch codec. Now, the reason we've been in the FFmpeg folder is because the glitch codec is just a copy of FFmpeg. And what FFmpeg is a free and open source tool which uses a library of codecs to compress video, to turn one video format into another video format, which is what we're going to do. But we want to hack some of those codecs in that library so that when we compress videos, we also glitch them. So once that's done compiling, you'll notice your terminal stops doing a bunch of stuff. We want to go ahead and go back to our original terminal where we had compressed a video, and we're going to more or less do the same thing. First, type in glitch codec to run our glitch codec. Type in a space -i, another space, and then the name of the video you want to import. This time I'm going to import nic2.mp4. Then type in another space, and now the name of our new, what we want our new video to be. I'm gonna call mine nic2glitch.mov. Again, make sure it's .mov, and then hit enter to compress it. So these codecs, these compression algorithms, these assumptions, they deeply affect the life of images and media today. That's a quote from a professor at Lancaster University named Adrian Mackenzie, who's done a great deal of research and writing on the subject of codecs. And he says that at a phenomenological level, codecs deeply influence the very texture, flow, and materiality of sounds and images. Codecs catalyze new relations between people, things, spaces, and times in events and forms. And so the role codecs play in our ways of seeing the world is way more pervasive than we might imagine. Nearly every bit of media content that we encounter on television, on DVDs, on CDs we buy at stores, on MP3s we download to our iPods, and videos we watch online, they've all been compressed with codecs. And so the importance definitely becomes clear from an economic standpoint. McKinsey explains that codecs are a mosaic of intellectual property claims, often 700, held by entertainment, telecommunications, government, academic, and military owners. And the large patent pool attests to the significance of some of these codecs. So they play an important role in our sort of digital media landscape. So once your video is finished compressing, go ahead into your glitch home folder and open it up. So the glitch we're looking at right now is specific to the codec that we hacked, H.263, and even more specific to the piece of the file that we hacked. So if we went back to that H.263 data file and messed with another part of it, we'd get a different kind of glitch. If we went and chose a different file altogether, then we could get another kind of glitch. So there's a lot of possibilities here, a lot of room for experimentation. Another thing to make note of is that what we're calling a glitch is actually the combination of a couple factors. First, the misencoded or corrupted file, in my case, the nic2 glitch.mov file. And second, the media player that's interpreting that file. So if I were to take this video, save it on a USB stick, open it up on another computer with another media player or in another program, I could get an entirely different glitch. Or it might not open the file at all, and my glitch will get replaced with an error message. And so this is important because helps to realize that the glitch actually happens in between spaces, in between the misencoded or corrupted file and the container or frame, the program that opens up and interprets that file. Probably a good time for us to recap our workflow or hack flow. So in Ubuntu, you've got what's called workspaces, which is kind of like having different desktops, similar to the way Spaces works on a Mac. And the way you navigate through these is by holding down Control-Alt and then using your arrow keys. Now, I've got this set up with 4 workspaces by default, but you can have as many or as few as you wanted to. But I like working with 4. And in this first workspace, I usually open up the source code to the codec or codecs that I'm going to be hacking. In the second workspace, I open up a terminal to compile that source code. So remember, in order to do compiling, we need to be in the right directory. So type in cd space ffmpeg and hit enter. Then in this workspace, I open up another terminal, this one to run our videos through our glitch codec. Then in this last workspace, I open up the glitch home folder, which is where our videos are going to show up, so we can open them up and watch them. So this is probably a good time to mention that anything you do, any codecs you hack or videos you make on this DVD isn't going to get saved once you reboot or turn off your computer, because everything you're doing right now is just sort of being stored in RAM. So if you do anything that you like, it's probably a good idea to back it up to a hard drive or a USB stick or something. Also, don't forget what I said about the glitch being something that happens as a result of the misencoded file and the media player. So if you're getting a glitch that you particularly like, it's going to be a good idea to record that, to sort of document that, which is why I've included a program on here called Record My Desktop. And what this program is going to do is allow you to sort of screen capture any videos that you've got and make a sort of stable video file out of it, as opposed to these corrupted video files that we're running right now. So this stable file is going to be kind of like a document of your glitch that then you can open up in other computers, burn on a DVD, upload to the internet. But it won't really be the glitch. It's just sort of a document or stabilized version of this particular glitch. So let's go ahead and run through that process. First, make a change to the source code of a codec and save it. Then compile your new source code. And then when that's done, go ahead and run a video through your newly compiled glitch codec. So while that video compresses, there's one more important point that we need to cover about the nature of digital files, which is really similar to the nature of ideas. There's this great Thomas Jefferson quote that gets referenced a lot in these situations where he talks about the nature of ideas. And he says that the nature of ideas is such that no one possesses the less because every other possesses the whole of it. He who receives an idea from me receives instruction himself without lessening mine, as he who lights his taper at mine receives light without darkening me. And this is also true about digital files, right? So in economics, when a good is limited or scarce by nature, it's known as a rivalrous good. And this means first that my use or consumption of a good prevents others from using or consuming that good. And second, that in order to produce an additional unit of that good, we need to use up some sort of limited social resource that we could otherwise use to make something else. So say, for example, a chair. If I'm sitting on a chair, nobody else can sit on that chair. And if we want to produce an additional chair, we need to use wood and nails, which we would otherwise use to make something else like a desk or a table. Now, the cost of producing that additional unit is known as the marginal cost. So a non-rivalrous good is something whose marginal cost is zero. So, for example, ideas or information. Also, digital files are non-rivalrous, right? Because we can infinitely copy digital files at no cost. Additionally, my use or consumption of a digital file doesn't prevent anybody else from using or consuming that digital file, right? So economically, we understand that when we place the price of a non-rivalrous good above its marginal cost of zero, we create an inefficient market. And this is exactly what the proprietary commercial software model, which we mentioned before, does. It attempts to impose sort of unnatural scarcity on digital software. And once we know this, we can understand piracy to mean the refusal to comply with the industry's forced scarcity agenda. And this agenda just doesn't stop with software. It's also imposed on video files and music files and any kind of digital file via licensing and copyright. So this is why we're starting to see a sort of backlash against copyright known as the copy left and also what I like to call the copy middle. And the copy middle are those who sort of propose alternatives to copyright. So say, for example, Creative Commons, which works within copyright law to allow for certain creative freedoms like appropriation and remixing for non-commercial uses. Um, the copy left are those who oppose copyright and intellectual property altogether, right? This notion that ideas can be a form of exclusive property, which, like Jefferson said, is just unnatural. Um, so because of the nature of this project, I'm putting this whole tutorial out there, copy left, or perhaps more appropriately, copy it right, which is which is a sort of copyleft license or ethic established in the 1970s here in Chicago by video artists Phil Morton and Dan Sandine, from whom this project takes a lot of influence and inspiration. Um, and so for that reason, I'm going to ask that anything that you do that comes out of the use of this tutorial, any videos you make or cool hacks that you come across, that you share that and you put that back out there, copy left, by either emailing it to me or posting it as a comment on the blog or whatever. But of course, given the nature of the copyleft ideology, you don't have to do that if you don't want to, but it would be awesome if you did. Um, so let's watch that video. So the naturally occurring glitch is an unexpected and often perplexing event. This kind of intentional instigation of that occurrence can be called glitch art. Like I said before, glitch art can often establish this kind of healthy critical relationship towards digital technologies that's granted and encouraged by the freedoms that are emphasized within certain spheres. But these freedoms, which are essential to this kind of critical relationship, is not only withheld, but it's hidden and made illegal in other spheres. Glitching then can be a means to protest against these entities and their special interests, which deny us these freedoms. Glitching is a critique of the medium's structure, its material, and its politics. And the critical and intentional act of glitching demands this kind of freedom in order to be able to instigate, to explore, and to relate. Like I mentioned before, the glitches which occur by means of this tutorial exist as a result of two things. First, the misencoded file outputted from our hacked glitch codec, and second, the frame or the container used to view that file. So in this way, the glitch is ephemeral. It exists somewhere in between those 2 points. And as technologies upgrade and error checking protocols hoard in, this particular kind of glitch might cease to exist. And so this ephemeral nature can help us become aware of the complex and fragile digital dynamism at play today and the assumptions that we usually make to the contrary. This hack always exists in the present and never in the past because every use of the glitch codec necessitates a new destruction of the codec file at the code level, creation by destruction. The glitch codec tutorial itself can be discussed as glitch art, but it's important to note that this tutorial is something that's always experienced, not just observed. It's a process, not a product.